So first let me give you a demo here. So we'll take this, we'll take this table containing 2 million records. We'll have the degree of parallelism set to 1. So it's just going to have one process working on it. And we are going to sort that and see what is that we achieve. How you get the degree of parallelism set for any table. Select degree from user tables where table underscore name. You have to give the table name in caps, that is mandatory. Class underscore demo underscore large. So for this table with 2 million records, we don't have any parallelism. So we are going to see what will be the execution plan for this. So for that we are going to use this tool, right? Explain plan for select star from class demo large. So I'm just going to sort it. So it is order by some variable, that is cost. Cost is a number inside my table. So I'm going to sort it. So when I sort it, I'm going to get the plan explained. So how will I view the plan? Select star from table. And I'm going to use this package. Explain.display. So this is going to show me the data. So when you take a look at this, how the sorting was done, the entire table was accessed. There was no parallelism, a full table scanned serially. And then sort order by. So every record was read and sorted. There was no parallelism here. And you can see the cost that's taken up here. It's 98467. So this is without parallelism. Now if I go and run this query with the degree of parallelism as 2. What do you mean by degree of parallelism 2? We are going to have 4 threads, 2 producers and 2 consumers, parallelly reading my record and sorting my record. So we are going to take a look at this. Let's go and run this. We can even perform this. We can say explain plan select. I can give an oracle link here. Select star plus use for. What it means is I'm telling to the optimizer have a degree of parallelism as 2 for my query. So that is what we are doing, and then the remaining things are the same. Select star from what table is it? It is class demo large. Order by cost. The same query. Now we are enforcing a parallelism of 2, which means we'll have 4 threads, 2 producers and 2 consumers parallelly working on the data. So we'll go and so it is actually explain plan for. I missed a keyword here, that's why it's giving an error. So now let's go and view the plan. How will you go and view the plan? You're just going to say select star from table, this package. So now when you go and view this plan, this is where we understand some kind of parallelism has been achieved. So there is a block iterator. Your table gets divided into blocks, and then this block iterator is used by the producers to get the data from the blocks. And px send range. What does that mean? Using the range, the producers distribute the records to the various consumers. And finally receive. Receive is where the consumers receive the record, and then they sort it in parallel. Finally, all the sorted partitions will be sent to the coordinator who will merge it and give you the result. This is what we discussed in depth in the last class. And you see the cost has reduced from some 94767 something to 54686. So the optimizer executes a query that has the minimum cost. You can very well see here when you're going in for parallelism, your cost gets reduced. Now we'll go ahead. We'll have an execution plan for the same sorting with a degree of parallelism as 4. What do you mean by degree of parallelism as 4? We'll have 4 producers, 4 consumers parallelly reading, distributing the data and sorting it. So we'll go and view a query plan for this, and we'll see how that one works. How can you execute this? Let me put that query. So it's explain plan for sorting this use table with a parallelism of 4. So you can go and view this query plan. So it's going to throw you the same kind of a query plan, almost the same, but you see the cost of running this query has come down to 27343. when you increase the degree of parallelism, the cost of running the query reduces. See, what you are seeing here is again the same thing. You are going to have the entire table, class demo logs, accessed in parallel using block iterators by all your producer processes. And then these processes distribute, see P arrow mark P means a producer distributes the records from the table to all the consumers. So parallel processor distributing records to other parallel processors. And once when this consumer receives it, it goes with a sort. After sorting, you can see a P arrow S. What it means, after sorting, everything should be serially accessed and merged. So it means from parallel you are going to a serial execution. So that's what the final thing. So all the parallel partitions will be serially merged, and then that is the job of the coordinator. So coordinator is the final person who merges the sorted partitions and gives you the result. So what is that we understand is when you increase the degree of parallelism, your cost reduces, but that doesn't mean for a very small set of data, I'm going to have a higher degree of parallelism, then your efficiency will go down, because you don't need a higher degree of parallelism for lesser number of records, because again running threads in parallel and merging them takes time. Okay. So what you can do is, you can always leave it to the default degree of parallelism set by Oracle internally, so that it manages the things for you. The optimizer takes a decision for you. The next thing that we are going to look at is sorting partition tables. So earlier this class demo logs was not partition. We learned so many different types of partition techniques, right? What are those? List partitioning, round robin, hash partitioning, and then range partitioning. So partitioning in the sense you're going to split the tables across different table spaces, or you're going to have the tables across different disks. Therefore you achieve a lot of I/O parallelism. Reading all the data from one disk will take some time, but you split the data on 5 disks, parallelly you can read data from 5 disks. So that is I/O parallelism. So when you partition this data, say this big table with 2 million records is actually say partition as partition P0 and partition P1. And now how will this sorting work? So how the sorting works is, the producers actually what they do is they read the records from all the partitions. So again you will have this block iterator coming in between. So block iterator. So what this block iterator does is it splits the records into a set of blocks, gives it to each producer. So a producer can read records from the table in a chunks of blocks. We are not directly matching it as one producer goes to one partition and takes the record. It's totally purely based on blocks. So block iterator means a producer uses a set of blocks and then it reads the records and blocks from the table. So you have block iterator coming in here. So again the process is the same except for this block iterator which will iterate and then get all the records from all the partitions. So the producers use a block iterator to retrieve records in blocks from all the partitions. That's it. And then what it does, again it range distributes. So it reads a record, based on which range it should go to, it distributes it to that consumer. So range distribution happens. Once when a consumer gets a record in that virtual table, it's going to go and start its operation, sorting. So every consumer will be sorting a set of records, right? So this set is again going to be given to the coordinator. This coordinator is nothing but a serial process. So it's going to get every batch and then merge it and then give you the output. So when you go in for partitioning, there is no big difference except for the producers scanning every single partition in blocks. So let us go and take a look at a demo for this. So I have created a table S. This table S contains 4 million records. And I have created 2 partitions for S, that is partition P0 and P1. And I have used hash partitioning to partition my records. So each partition contains 2 million records. P0 contains 2 million and P1 contains 2 million. And the degree of parallelism we are going to have for this is 4. So we are just going to run a sort query on a partitioned table, that's it. So we have certain questions here. I told you that S is partition, right? How will you go and verify how many partitions a table has got? For an existing table, how will you go and check how many partitions it has got? I said it has got 2 partitions. What is the partitioning type for table S? Say I said it is hash. It can be range or round robin or list, but how will you go and check what is the type of partitioning that happened on a table? What is the degree of parallelism for S? How can you check that? And we have to alter the degree of parallelism to 4 and then we have to sort our data. So what we'll do is we'll just go and execute and check how many partitions my table S has got. So for that we have to go to this SQL plus. Let me clear screen. So I have created this table. Let's check how many records I have in this table. Count star from S. So this is where we need optimization. You know, when you do a select itself takes so much time. When you have 4 million records. So when I am going to parallelize select with the degree of parallelism of 8, then I am going to get a quicker response. But still, you know, we are waiting. Just for 4 million records, we have to wait for such a long time. And now, how do I know that how many partitions I have created on table S? For that, I have to run a query. Select partition underscore name from user underscore tab underscore partitions. Where table underscore name, you have to give this in caps, that is yes. So as I told you, I have created 2 partitions. So each partition, how many records it contains? Around 2 million records. So select star from, I should never do a select star from, then I have to close my process. It's going to run 2 million records here. Select down star from, yes, how will I know from which partition how many records I have? I'll give partition and then I'll give P0. So now, so again it's going to tell me how many records in each partition. I just run it for one partition. It's almost 2 million records in one partition. Now, how did I partition this? What is the partitioning type I have used? For that, what we have to do is select partitioning type from user underscore part underscore tables where table underscore name is equal to yes. I think this one should work. What we achieve from this query is we'll know what kind of partitioning was achieved on that particular table S. So we have established hash partitioning and derived 2 partitions. How will I go and view the degree of parallelism on this table? Select degree from user underscore tables where table underscore name is equal to, we have to give it in capital letters. Always give the table name in capital letters. So it says degree of 4 and it's already set to a degree of parallelism, that is 4. Now you can go and run your query. What is that query? It's going to be sorting that table. That's it. So let us go and explain. Let's go and sort that table. Explain plan for select star from table is yes. This is a partition table. Order by is the sort thing. Order by cost. So it's having 2 million records in each partition, whereas it's going to sort all the records in all the partitions. That is the idea here. Now let us go and see what is there in the output. Select star from table. We have to say DBMS underscore xplan.display. Right. Let's go and view this. Yeah. Okay. So this is the output I have received. Let's go and check what's happening here. How it is different from the previous thing. Here we have the partitions, 2 partitions, right? So you can take a look at this. Table S, the entire table is accessed using a block iterator. What do you mean by block iterator? Producers use the block iterator to iterate the table in blocks. Okay, and then this is range distributed to all the consumers. So what this block iterator does is, you can very well see the difference here. This is partition stop, partition stop. So what is this? Partition start and partition stop. The block iterator runs for both the partitions 1 and 2. So that is the only difference we see here. So it runs across all the partitions, it range distributes it to the consumers, consumers sort it, and then they give it to the coordinator. So how many producers and consumers we have here? 4 producers and 4 consumers. Because our degree of parallelism is set to 4. But we should be able to say what is the distribution here. What is PQ distribution? It says range. What do you mean by range? You read every record, based on the range you are going to distribute it to other consumers. So you are going to know what is this. You are going to know what is P arrow P, P arrow S. All these things you are going to know. You are going to know what is this TQ1 000 or TQ1001. These are nothing but virtual tables that is used for sharing records between producers and consumers.